All right, we are now taking our factoring that we've been practicing, and we are now putting it into expressions. And we're going to multiply, simplify, and divide these things. All right, so we're going to have to use our factoring skills to do this well. So it's good practice of what we've been doing and just applying it in a little different situation. All right, so you might be able to look at this 24 divided by 9 and realize, yeah, that's going to simplify. Okay, but let's make sure we understand the principle behind it. Okay, so if I listed this out as 8 times 3 over 3 times 3, okay, I could see that this is the same as 8 divided by 3 times 3 divided by 3. Well, what does 3 divided by 3 equal? 1. Okay, so I can then cancel those things out because it's 1. Anything divided by self is 1. So my final simplified answer is 8 over 3. All right, so remember, any factor, that could be a number, a variable, expression, divided by itself equals 1. That's the principle that we're going to use. So we're going to take something that's more complex. We're going to factor it out, see that like factors that are above and below the quotient line, and then cancel them out. Okay, so let's see which of these that applies to. Okay, so this is going to help us to clarify what is and is not truly a factor. So I can look at this first one, see in parentheses x plus 4 times parentheses x plus 1 divided by parentheses x plus 4 times parentheses x minus 3. I can see the x plus 4 is the same on top. On bottom, it is exactly the same, which is important. So I can cancel each of those out. And so, yes, this principle applies, and I can simplify simply x plus 1 over x minus 3. If you use parentheses, that's fine, but you don't have to in this case. All right, but what about this next one? I see that there's a 3x on top, 3x on the bottom. Can I just cancel them out? Think in your head, answer that question. Okay, the answer is no, I cannot. Okay, these are not factors in and of themselves, they are terms. Okay, not factors. Okay, it is important to remember that these are kind of glued together. Okay, 3x plus 1, once I have that plus 1 in there, it's glued, it's a package deal. And so unless I have 3x plus 1 below it, I'm not going to be able to just cancel out a part of it. Okay, so that's a place where students tend to get tripped up on. And so just keep that in the back of your mind, and we'll see through example problems how that works out. Okay, so looking at the next one, we got 3 parentheses x plus 4 divided by 3 parentheses x minus 1. Well, x plus 4 and x minus 1 are not the same, so we can't cancel those out. But we do have a 3 in the front. So 3 divided by 3 is 1. And so, yes, this applies. Okay, so I can simplify it simply as x plus 4 over x minus 1. If you put parentheses around each of those binomials, fine, but you don't have to. All right, so if we look at this one, I see there's an x on top, x on the bottom. Okay, but again, those are terms, and so no, this does not apply to cancel anything out. That is the most reduced or simplified version of that. Okay, that plus and minus kind of glues them together, and I can't rip them apart. Okay, so with that being said, never, ever, ever cancel terms. Okay, and that it is separated by a plus or minus. Okay, only factors. Okay, and those are separated by multiplication. All right, So if we look above to make sure that we're applying that and understanding that, all right, that's where if I have in this second one here, 3x plus 1 and 3x minus 4, they're separated by a plus sign. Okay, they're not separated by a multiplication sign. If it was 3x times 1 and 3x times 4, then yes, I could cancel that 3x on top and bottom. But since they're adding and subtracting, I cannot. They're glued together. But I could look at the next example and see 3 times parentheses x plus 4, 3 times parentheses x minus 1. Since they're multiplying across and have the exact same thing on top and bottom, I can cancel those things out. Okay. All right, so let's try this out here. Okay, write the following in lowest terms. Okay, so one thing you could do early on, okay, is you can just really kind of break this down into its parts. Okay, so this is 12. You can even break that down more so into 4 times 3 times x times y times y. And those are all being multiplied up top. All right, so now, because it's all multiplication, okay, I can look and see what's exactly the same on top, what's exactly the same on bottom. Some people for this will just put a 12 down there, but what we want to do is see those larger numbers as like multiplication problems of smaller numbers that might help us to cancel things out. So I can see that I have a 3 on top, 3 on bottom. I can cancel them out. I got an x on top, x on bottom. I can cancel that out. I got a y on top, y on bottom. I can cancel that out. There's nothing that's the same on top and bottom anymore, so I could just now simplify it to that. It's a lot simpler, okay, than it was. All right. So let's take a look at this second one. Okay, it's a little bit more complicated, okay, but let's see what we can do. Okay. All right. So 3x minus 6, k squared minus 4. Okay, so I can take out a common factor, 3, and that's going to leave me with k minus 2. And then here, hopefully we can see a binomial with two terms that one is squared and one is just the number. And that should be a little red flag that, oh, this might be something that I'm familiar with, kind of a special case, okay, where we got a squared minus b squared. Okay, remember, this is the difference of squares, and this becomes a minus b, then a plus b. So I can factor that out. So that means that this can be k plus 2 and k minus 2. Okay. All right, so now I have a k minus 2 up top, k minus 2 on bottom. I could cancel each of those out. And my final answer is simply 3k plus 2. All right, so we always got to be looking for those special cases, okay, and making sure that we are checking for those. It'll help simplify problems. All right, let's try this one now. Again, these things can look really intimidating, but if we break it down, okay, take out greatest common factors, take out, try to factor these things out, we're going to find we might be able to do these a little bit easier than you think. All right, so let's try to factor out this top one, 2p squared plus 7p minus 4. Okay, so kind of using my rules from previous notes that we've done, okay, I'm going to break these into two binomials, and I use the last sign to help me understand what the signs are going to be. If I have a negative last term, then I'm going to have one positive and one negative sign after I factor it. Okay, so I undo f first, so that's 2p squared. Okay, so I'm going to get 2p on one side and then p on the other side. Okay, so then I undo L, which is the 4. Okay, so I have factors of 4 and 1 or 2 and 2. Okay, and so I'm going to look at this and say, well, I can't have a greatest common factor, so I can't put 2 or 4 in here, but I can put a 1. Okay, and then that would mean a 4 over here. Okay, so if I FOIL these things out, okay, I get 2 times p is 2p squared. 2 times negative 4 is negative 8p. 1 times p is plus p, so that gives me negative 7p. And then I got minus 4. So I get negative 7p instead of positive 7p. Whenever that happens, all I do is flip the signs. Okay? So I can just flip the signs. Now I get positive 8p minus 1p, and I get or I get positive 7p. Okay? All right, now the bottom down here, can't really factor it out in the same way, but I can take out a 5p. So if I put a 5p out front, if I divide 5p squared by 5p, I get p. And then if I take a 5p divided by, or 20p divided by 5p, then I'm going to end up with plus 4. So now I have a common expression on top and bottom, these. And so I can simplify this to 2p minus 1 over 5p. All right, so that's the process that we're dealing with. Okay, we're using our factoring skills. Okay, we're trying to find common factors that we can then reduce. Okay. All right. So that's dividing them. Now what we do when we multiply. Okay, so just a reminder. Okay, if we have this 4/5 times 3 over 2, you can just multiply across and end up with 12/10. But what you can also do is see that, all right, I got these two numbers. 4 is basically just 2 times 2. And so if I can break it down into its multiple or factors, then I can cancel 1, 2 down here and 1, 2 down here. So then I get 2 times 3 is 6 over 5, which if I just had multiplied across and gotten 12 over 10, I would have divided it by 2 and ended up with 6/5 as well. Okay, and so again, we're trying to simplify these things. All right, so if I look at this, I might see that this is 3 times 5. I might see this is 2 times 7. Okay, and so this is a times a. Well, that means that I got a 5 up there and a 5 down there and an a there and an a there and a 7 there and a 7 there. Okay, well, now all I got on top is a 3a, right, there and there, because I've used those. And then all I got on the bottom is a 2. And now I'm done. Okay, so a few different ways that you can simplify this. I mean, you could multiply it out and you would end up with, 105a squared divided by 14 times 5 will give you 70. Then just kind of subtract using your exponent rules. A squared minus a just gives me a. And then I would just keep dividing things down. I would end up with the same thing. Just this, now I can speed the process up a little bit. Okay. And this is where it becomes really, really helpful. And so now I don't want to multiply everything across, right? Not have to FOIL everything. And it just gets really complex really, really quickly. What I'd like to do is see if I can take out a common factor of each expression. So in this case, I could take out a 5. I'm going to end up with x minus 3. If I go below here, I see 3x plus 9. I can pull out a 3 and end up with x plus 3. Okay, up top, I can pull out a 4, and I'm going to end up with x plus 3. Then down below, if I pulled out a 6, I would end up with an x minus 3. And so if I cancel out like terms, okay, I'm going to end up x plus 3 gone, x plus 3 gone, x minus 3 gone, x minus 3 gone. Okay, and from here I could just multiply across to get 20/18. Or, okay, I can also reduce this down to 2 times 2, and there's the 2 times 3. So then I can cancel out a 2 and a 2. And now I got 5 times 2 is 10. 3 times 3 is 9. So I have it completely simplified at that point. Okay. Again, just trying to show you ways that you can get down there a lot easier than what it might look like at face value. All right, so remember when we divide fractions, we have to multiply and flip, okay, the second fraction. So this becomes 4/5 times 3 over 2. Okay, and so in the same fashion, I can then change this to 2 times 2. And then that cancels out, I end up with 6/5. Okay? And again, if I would have just done 4 times 3, I'd get 12. 5 times 2 would give me 10. And I'd be able to reduce it down to this as well. So at that level, it doesn't seem like it makes much of a difference. But as you hopefully saw with the previous examples, when you get to more complex things, that's when the value of doing this really, really pays off. Okay, so take a second and try this second one. Based off the work we've done, pause the video, try it out yourself, and see how it goes. And restart and check. Okay, so this is going to be changed to t minus 2 over 8 times 6 over t minus 2. Okay, and so I can then break this down into 4 times 2, and this even more into 2 times 2, and this into 3 times 2. So now I got t minus 2 gone, t minus 2 gone. I got one of those 2's gone, another one of those 2's gone. And I end up simply with 3 on top, 2 times 2 on the bottom, which gives me 4, 3/4. Okay. All right. Now, don't let this next one intimidate you. It is the same process we just did. Okay. So now I have to factor out for each of these first, and then see what I can do. All right, so I'm going to do the left side first. I'm going to factor that. I got 2k squared minus k minus x. Okay, and so I got the minus, so it means I'm going to have a 2k and a k. Okay, one of them is going to be plus, one of them is going to be minus. I'll just throw them in now. Not sure if that's the right order, but we will see. Okay, so 1, factors 1 are 1 and 1, so I know it's going to be 1 and 1. All right, so just to double check, all right, 2k times k gives you 2k squared. 1 times negative 1 gives me negative 1. I get negative 2k, and then a positive k gives me a negative k. So I'm good. Okay. All right, then do the same thing on the bottom here. I see plus. Okay, then I check the middle term. It's plus again, so I know that's going to be 2k plus, and then k plus. Okay. So then I need to figure out, well, what things will multiply out using the factors of 3 in order to get to 5 in the middle. And so I could do 1 here and a 3 here. So I'll get 2k, 3k, adds up to 5k. So I'm good. All right. Now I need to flip this second one. So I'm going to factor this part first. Okay, so I got a negative, so I'm going to have a positive and a negative. Again, order might have of the signs might need to be changed, okay, but I'll work it out from here and figure that out at the end. So now I have negative 3, so I know I'm going to use 1 and 3. And so it's just a matter of, well, which one am I going to use? I need to use those to get a positive k value. Okay, so let's say I did 3 here and 1 there. I get 2k times negative 1 gives me negative 2k. 3 times k gives me positive. Add those together, I get positive k. Awesome, golden. Okay, then I look at this here, and that's going to go down below. Okay. All right, so I see that we have 4k squared minus 1. Okay, so I'm going to need to do 2k and 2k. All right, so it's a difference of squares, so it's going to be a +1 and a -1. Those will multiply out to get -1, and then it'll be plus k2 or 2k minus 2k, and those will cancel out. All right, so I've now factored those out. It can be a little bit time consuming, that is true. And now I'm going to go through and try to eliminate as many of these factors as possible and simplify. Okay, so again, they got to be the exact same thing on the top, exact same thing on the bottom. All right, so 2k plus 1, I see up here. I see another one down below. I can cancel those out. Okay, k minus 1, I don't see that on the bottom anywhere. So I'll go to 2k plus 3. Yep, I see one there. I see one there. Okay, so we're good. K plus 1, I don't see that anywhere. 2k minus 1, I don't see that anywhere. So I've eliminated half the terms. So the answer would just be then k minus 1 times k minus 1 over k plus 1, 2k minus 1. Okay, you could have listed it as, k minus 1 squared. That would be fine too on top. All right. All right, so these ones down below are just the same types. Okay. So you can pause and try and solve these yourself, okay? Or you can watch me as I walk through them, all right? So I'm going to factor r squared plus r minus 6. So that's going to be r, I got minus 6, so one of them is going to be plus. One of them is going to be minus. Okay, they need to multiply out to -6, so 3 and 2 makes sense. Okay, and so I'm going to have the negative be the larger. Oh, nope, I'm not. Put that. Have the negative be positive, because I'll get plus 3r, then minus 2r, then going to be a positive r. And the bottom, see minus down here, so I know it's going to be r plus, then r minus. Not minus 1, r minus. Okay, so I need to multiply out to 12 and add up to, or negative 12, add up to positive 4. Okay, and so I'm going to want to put my larger one that's positive, my smaller one that is negative. See, plus 6r minus 2r will give me a plus 4r. Times. Okay, so now I'm multiplying. So I'm flipping the top and bottom. So I'll have r minus 1 on top, r plus 3 on the bottom. Okay, then I can go through and cancel out like ones. So I see that I got r plus 3 here, r plus 3 there, r minus 2 there, r minus 2 there, leaving me simply with r minus 1 over r plus 6. And that is my final answer. All right, last one. All right, so take a minute, pause, and really try doing this one individually. Okay, it's good factor practice, and then cancel it out and check your answer at the end. Okay, so I'm going to see this is going to be m. We got pluses, so that makes it a lot easier. M plus. One's going to be 2, one's going to be 1. On the bottom down here, I'll have, again, plus plus, which is great. All right, one's going to be 4, one's going to be 1. So those will add up to 5, multiply out to 4. Okay, up top here, again, we're going to have m plus. M plus. Okay, what will multiply to 24 and add to 10? Okay, 6 times 4. And so, again, which order doesn't matter. We're good there. This is going to be m plus again. And m plus again. So what multiplies out to 6, 2, and 3. Okay. All right. Now, I can take a look. I got m plus 2 down here, m plus 2 up there. I got m plus 1 there, m plus 1 there. I got m plus 4 here, m plus 4 there. And the only thing I got left over are those two terms. So I get m plus 6 over m plus 3. Okay, so again, at this point, a lot of students will be like, "Oh, great! I could just divide them straight through and see that is n divided by m is 1, and 6 divided by 3 is 2. So the answer is just 2. That is not possible, not correct. Okay, with that plus, I cannot reduce it down. This is the final answer. If it was 6m divided by 3m, I could do exactly what I just said. I could divide by m to get 1, 6 divided by 3 and get 2, and the answer would just be 2. But with that plus sign, I am not allowed to reduce it any further, and so this is my final answer. All right, so hopefully, okay, this is good factoring practice, and you can see why factoring can be really, really effective at turning seemingly complex and difficult problems into much more manageable problems. All right, come with any questions. Make sure you write this stuff down. Try the homework and come to class ready to ask any questions. Hope you guys learned something. Thanks for watching.